Alrighty, let's do a little math review here. I wasn't even set up and I started the video, like quality's going downhill. Before we get started, let's give a little shout out to YouTube user Smart Cookie, who's not even in our class and is watching Math 20-1 videos, liked and subscribed my videos. No big deal. Maybe some of y'all could follow suit. Even said, "You're so funny, I wish I was in your class." So maybe we should appreciate a little bit about what we have before it's gone, people, because Math 20-1 is almost over. And you know what? We might never be reunited again. So enjoy while it lasts. Grass ain't always greener, tell you that much for free. All right, yesterday, actually it was today. Today you had a quiz, and you are now going to review that quiz. Hopefully you're watching this video at lunch or after school or something, trying to get a little study time in because you've got a test tomorrow. The first question was your email address. You didn't have to write it. It was automatically there. You definitely got that question right. Question 2, what is your name? Hopefully you remembered your name and you got that right. Question 3, who is the best teacher you have ever had? Honestly, it's a trick question because every answer was correct. So if you give a little shout out to Mr. Kennedy, that's awesome. If you decided you want to give a shout out to Matthew Kennedy, that is even better. If you put both answers, double the marks. That's all I got to say to that. And if you tried not to answer, I made it a required question, so you had no choice. Number 1, the real number 1. Okay, this question says the number of non-permissible values is... Non-permissible values. Those are things that cause you to divide by 0. Just for the record, this question used to say, after simplifying, the number of non-permissible values is. I want to make it very clear that the number of non-permissible values never changes. The way it is at the start of the question is the same way it is at the end of the question. Okay, and I got rid of that wording after simplifying because I didn't want to confuse anybody and try to trick them into the wrong answer. The non-permissible values is the same at the start of the question and it's the same at the end of the question. Non-permissible values are things that cause you to divide by 0. So if I look at this question, right here, there would be a non-permissible value. X could not equal 0 because 9 times 0 would be 0 and we'd be dividing by 0. Right here, there's a non-permissible value. B cannot equal 2. 2 minus 2 would be 0, therefore making us divide by 0. This 6 will always be 6 because there's no variable there. There's no way I'm ever going to make that 6 0. So my only non-permissible values are X cannot equal 0, B cannot equal 2. That means the answer is C. There's 2 non-permissible values. Number 5, when the expression below is fully simplified, the denominator is. Okay, so they're only looking for the denominator. The reason we do that is so that you can't just put numbers into the answers and then see which ones are equivalent. So you'll notice a lot of questions say the numerator is or the denominator is. That makes it so you actually have to do the question. When I look at this question, I want to fully simplify it. First thing I do is I factor. I can't factor that, but I can put brackets around my binomials, right? So that's 5x minus 2 in brackets now, and then x minus 5 in brackets now, like that. The next thing I want to do is check to see what operation I'm performing. This is division. So that means I need to kiss and flip the second fraction. So I turn it into a multiplication, and then I flip the second fraction. The first fraction stays the exact same. Because it's multiplication now, I can combine this to become one fraction. On the top, I always put the monomials first, followed by the binomials, like that. In the denominator, I put 3x, and then I put x minus 5. I do not actually expand, right? I don't multiply this in. The reason I don't do that is because if you multiply it in, you can no longer cancel things out because you no longer have multiplication on the top. You would have one big statement. So you want to leave it in factored form like it is right now. Then you want to try to cancel out things top and bottom. My x squared and my x are both monomials, so they can cancel out. I will lose one of my x's on the top and the x on the bottom, making my final answer x, 5x minus 2, divided by 3x minus 5. Making your answer D. The denominator was 3 times x minus 5. Awesome. Number 3, sorry. Simplify that thing. To simplify, first thing I do is factor. I can't factor that thing, right? But I am going to put brackets around my binomials, like this. The next thing I want to do is check what I'm doing. In this question, I'm doing addition and subtraction. Addition and subtraction requires a common denominator. That p divided by q, or p times q, remember, does have a denominator of 1. So it has to get a common denominator just like everything else. When I get my common denominator, this one has a p, so this one needs a p, top and bottom. And this one needs a p, top and bottom. This one has a q, so that means this one needs a q, top and bottom. And this one needs a q, top and bottom. Giving me this. I have p squared q squared from my first fraction divided by pq minus q times p minus q divided by pq plus p times p plus q divided by pq. Now that you have a common denominator, you can turn this thing into one fraction by just basically combining the entire top, writing it as one big statement. So p squared q squared minus q, p minus q, plus p plus q, divided by pq, like that. So I took my original question, I got a common denominator, which allowed me to write this as one fraction. Once you have one fraction, your goal is to add and subtract, right? So I need to add and subtract these top things. I can't do that unless I expand. So I need to expand that q in, just to make it clear. That's a negative q I had to expand in. And I have a positive p that needs to expand in. If I do that, I get p squared q squared minus pq plus q squared plus p squared plus pq divided by pq. Just so you can see where things came from, my blue stuff up here that I expanded in blue, that's right here. My red stuff that I expanded up here, that's these ones. And the reason we expanded was so we could add and subtract like terms. Negative PQ and positive PQ would cancel out, giving me an answer of p squared q squared plus q squared plus p squared divided by pq. Woo! That is a hard adding subtracting question. Just going to throw it out there. The answer should be C. Cool. Cool. If you watch Community, cool. Number 4, simplify. All right, to simplify, you need to first factor. You can't factor this, but you can for sure put brackets on your binomials to remind yourself they're kind of packages. They're stuck together. The next thing you want to do is check what type of question you have. It's subtraction question. That means you need a common denominator. This thing has a common denominator. That means you can now write this as one statement. So it's 7d minus 2d divided by d plus 6. Once it's a common denominator, you want to add and subtract the tops. The 7d minus 2d would equal 5d divided by d plus 6. There you go. Answer was, ho, ho, ho. B and C are the same answer. The difference between B and C are the non-permissible values. So your non-permissible values come from the start of the question. It's what causes you to divide by 0. If I look at the start of the question, in both fractions, d cannot equal -6. -6 plus 6 would be 0. Can't divide by 0. That means B is my answer, not C. Number 5. First things first, I want to factor. I can't factor this, but what I can do is I can put brackets around. Second thing I do is I check what kind of question I got. It is a subtraction question. That means I need a common denominator. If I look at this, it almost looks like I have a common denominator, but I don't. The reason I don't is because this is n plus 6 squared, meaning that there's really 2n plus 6s. So if that one has 2n plus 6s, this one needs 2n plus 6s. So I multiply the top and the bottom by n plus 6. That gives me 1 times n plus 6 minus 4 divided by my common denominator of n plus 6 squared. I kind of skipped that step, so I just already wrote it as one fraction because I knew I had a common denominator. Once I have a common denominator, I need to expand on the top. So I'm going to multiply that 1 into the brackets. That gives me n plus 6 minus 4 divided by n plus 6 squared, giving me n plus 2 on the top, n plus 6 squared on the bottom. If you look at your answers, you will see the answer's D. It is D. That is great. It is D. All right. Been pregnant for way too long. You heard that song? It's on TikTok. I think it's a TikTok thing. I don't know. I saw it on Snapchat, but I'm pretty sure it's just a TikTok thing. It's pregnant people singing and dancing. If you're your baby mama. Yeah. I'll stop singing. That was rude, actually, of me to sing. Nobody wanted that. Number 6. When the following is fully simplified, the numerator is. So it wants me to simplify. I know my first step to every question is factor, factor, factor. So when I look at this question, A on the top, it can't factor. In the denominator, though, different story. I can square root that thing. It is a difference of squares, no questions asked. That means I have A minus 12, A plus 12. The order in which you write those does not matter. Minus 3A minus 1. I can't factor that, but I can put it in brackets, which is just a good old habit. In the denominator over here, I can definitely factor this thing. You're going to do diamond method. Things that multiply to be negative 24 and add to be positive 10 would be A. I thought I messed up the letter there for a second. A plus 12, A minus 2. 12 minus 2 times negative 2 is negative 24. Positive 12 minus 2 is 10. All right. Factoring step complete. Second step is state your NPVs, which we always do, right? Third step. Now I got to check what type of question I have. It's subtraction. That means I need a common denominator. This, A minus 12, has to be in both things. It is not. So I have to multiply it over here, top and bottom. This A plus 12 has to be in both fractions. It is. This A minus 2 has to be in both fractions. So I multiply it to this one, top and bottom. This now gives me a common denominator, so I can write my thing as one fraction now. The first fraction became a times a minus 2 minus the second fraction was 3a minus 1, a minus 12, divided by a minus 2, a plus a minus 12, a plus 12. Common denominator completed. After you have a common denominator, your goal was to add or subtract these tops. You can't do that unless you multiply. So we are going to multiply this a into the brackets to become a squared minus 2a minus this thing right here needs to distribute. When you do that properly, you should get 3a squared. Then you should have negative a minus 12 times 4, 36a. That would be negative 37a's. Right? 12, 24, 36, negative 1. Yes. Okay. And then negative 1 times negative 12 would be plus 12. The trick to this question. On my A's, on the red, I've multiplied properly. On the blue, I've multiplied properly. However, I wanted to subtract this blue stuff. So that means I need to put brackets around that blue polynomial. I have 5% battery left. Oh yeah, we're good. I plugged in. We're safe. That's like when your cell phone like hits 2%. Like how far do you go until you plug it in? Anyway, that negative symbol has to go into all those things in the blue. So there's still brackets around that blue polynomial. And then the negative has to go to each term and change the symbols so that you actually get this. You get a squared minus 2a minus 3a squared plus 37a minus 12 divided by that common denominator. A minus 2, a minus 12, a plus 12. If there's a spot you messed up, that's most likely it. You most likely forgot to distribute that negative to everything on the right side. All right. The reason you did all that multiplication was so that you could add and subtract the tops. Like terms go together. A squared minus 3a squared becomes negative 2a squared. Negative 2a plus 37a becomes plus 35a. Negative 12 becomes negative 12. The question said, what's the numerator? That's my numerator. It's D. Beautiful. All right, number 10. If you could like and subscribe to one YouTube channel and be forced to watch it for the rest of your life, which channel would you choose? Why Mr. Kennedy's YouTube channel, of course. It's the greatest. Ha, no brainer. That's the right answer. In fact, this question is so easy, it tells you that this is the wrong answer. But if I had to put money on who chose that anyway, I am going to go with Kellen. I just have a feeling in my bone that Kellen will click a wrong answer. Maybe that's a feeling from last test when I only had very few people sass me for giving them a wonderful formula sheet, and you were one of them. I don't forget. People don't forget. People don't forget. All right, next question. Number 7. Number 7. All right. This graph's a linear function. Which graph below represents the reciprocal? This is what we were just doing, right? So to reciprocate, there's 3 steps. First step is to draw your asymptotes. Asymptotes happen in 2 places. The first one is that it happens on your x-axis every single time, right? The other one is at your x-intercepts when you're looking graphically. If you had the equation, it would be where your NPVs are. But graphically, it's at your x-intercepts, which appears to be right about here, at about a half. A little bit less than that. The second step is to always put your invariant points. Invariant points happen at y equals positive or negative 1. So an invariant point is right there. Invariant point is right there. The third step is then to reciprocate. When you reciprocate this thing, you put your pencil on your invariant point and you go towards the asymptotes, like that. Now, this being a digital test, it's probably pretty hard for you to actually draw it. But you should have been able to kind of look and figure out where things were going to end up. If you look at your answers, actually all you need is the asymptotes, and I think you would have figured this out. Oh, actually, sorry, A has the right asymptote. If you look at B has a diagonal asymptote, and D has a diagonal asymptote. And those things aren't ever going to happen, not in our course. So that left you with A or C to figure out which one to answer. A would have looked like this. C would have looked like this. So that means C is definitely the right answer. If she obey number 8. Oh, domain and range. We haven't talked about domain and range in a long time, so why not throw it at you, right? What are the domain and range of the reciprocal function of this linear function? Okay. Reciprocal. Okay, so reciprocal of this thing would be y equals 1 over negative 2x minus 4. And if you were to graph that thing, there's two things that happen. You're going to get asymptotes on the x-axis. And then you're going to get another asymptote at 2, right? Because my NPV is x cannot equal 2. I'm going to draw it right over here. Cool. I don't even need to know what this graph looks like, as long as I can understand what those asymptotes are saying. My horizontal asymptote is saying that y cannot equal 0. It can be anything else, but it cannot equal 0. My vertical asymptote was telling me that x cannot equal 2. So if you look at your answers, like caramba, there isn't an answer here that matches. Why not? Oh, sorry, that's why. I was starting to freak out here. I mean, it's negative 2. X cannot equal negative 2. Because negative 2 times negative 2 would become positive 4. 4 minus 4 is 0. So that means x cannot equal negative 2. I put that asymptote in the wrong spot. This should have been over here. My bad. Now I can look at my answers. B is the only one with those restrictions, right? A said y cannot equal negative 2. That's not true. C said x cannot equal 4. That's not true. D said that x cannot equal 0. That's not true. So B was the correct answer based purely off of asymptotes. If you were to graph this thing, just for the heck of it, if you're like, oh, but Mr. Kennedy, how do you graph it? And I'm like, look, I'm a boss. I can graph anything. Your original graph would look something like this. Oh boy, what would it look like? Like this. That means my reciprocal function should look something like, well, I'm still on straight line. Your reciprocal function should look something like this. Which goes up forever, down forever, left forever, right forever. All right. Number 1, numeric response. We had 4 numeric response problems. Oh, that is so nice of me, making a third of your test numeric response. Like, what a guy. Number 1, what volume of undiluted hydrogen peroxide should be added to 6,500 milliliters of water to make 40% hydrogen peroxide solution? Holy smokes. What is this, chemistry class? What you don't want to do is take 40% of 6,500 because that's a sucker's move. So if you answered, well, let's put this in my calculator, 40% of 6,500. If you answered 2,600, you're a sucker. Sucker. That's 40% of 6,500. But that's not the answer. The reason why it's not the answer is if you were to mix this in, right? I'm adding this to 6,500. I would then have 9,100. And this is not 40% anymore. It is not 40% of 9,100. So that means you do not have a solution with 40%. You actually have less than that. So what you had to do was, as soon as you read this problem, you had to remember my all-time famous formula, which is crap added, or crap you add, divided by total crap equals percent. Okay, so however much you're adding goes on the top. However much you end up with, so whatever you started plus whatever you added, will equal your percentage. In this case, we don't know how much we add because it even says like what volume should be added. So I don't know. So I go X divided by my total amount of crap is 6,500, which is what I started with, plus X because I mixed it in, right? And I want that to equal 40%, but as a decimal, so 0.4. That's an equation we can solve. I have to get a common denominator. So that means I have to multiply this side by 6,500 plus X. And what I do to the bottom, I do to the top. My internet just went brutal on me. I don't know what's happening. Neighbor's probably stealing my internet or something. This allows the denominators to cancel out. And I now have X equals 0.4 times 6,500 plus X. To solve this, I'm going to multiply that 0.4 in. That gives me X equals 2,600 plus 0.4X. I need to subtract that 0.4 to the other side. So this is 1X minus 0.4X would give me 0.6X equals 2,600. And then I'm going to divide that by 0.6 to get X equals 4,333.33. And that is not a sucker's answer. That's the right answer. 4,333. That's how much crap you need to add to get your 40%. You're probably going to see another question like that, mainly because I love my formula. That's why. Number 2. This is a work problem. Our work problem followed the formula time together divided by individual time plus time together divided by the other individual time equals one job done. So no matter what the question is, if there's a job being completed, that's your formula. This said Karen and Benjamin are ecologists studying forest regeneration. Working together, they can count the seedlings on a research site in 2 hours. It takes Karen 8 hours to count the seedlings on her own. How long would it take Benjamin to count the seedlings on his own? Round the answer to the nearest tenth. This is a work problem. In this question, they're counting seeds in a forest. Sounds like a great job. it doesn't matter what the job is, right? We've seen all kinds of jobs. We've seen painting. I believe in your practice book, there's some sort of like making or delivering pizzas. We've seen cutting the grass. I talked about someone breaking into my neighbor's house, right? Like as long as there's a job being done, it'll always follow this formula where if you take the two fractions, you put the time together on the top, their individual times on the bottom, it'll always equal one job done. So to do this question, time together was 2 hours. Working together, 2 hours. So that means 2 is on the top of both my fractions. The bottom, the first one will be Karen. It takes Karen 8 hours. So her individual time was 8. How long would it take Benjamin? We don't know, so we put X, and it will equal one job done. Once you set this up, hopefully you realize you need a common denominator. This 1 is like 1 divided by 1, right? So this has to be multiplied by X, top and bottom, this by 8, top and bottom, and this by 8X, top and bottom. That gives me a common denominator I can cross out. I have 2X plus 16 equals 8X. To solve this linear equation, I subtract 2X to the other side. I get 16 equals 6X. I divide by 6. I don't know who's destroying my internet right now, but it is brutal. Benjamin's time on his own would be 2.67 hours. That's a rounded answer. All right. Number 3, because I can speak French. How about that for bilingualism? Number 3, when the following is simplified, it can be written in the form, and it gives you some form. Record your answers, record the values of A, B, C, and D in the numeric response box. Okay. When the following is simplified, simplify that thing. When you're done, it should look like this. So let's try it. To simplify this, I'm going to factor. I can't factor anything, but I can put brackets around everything. So I do that. I then am going to get a common denominator. This side needs to be a multiplied by x minus 3. This side by x plus 3. Now that I have a common denominator, I can rewrite this to be x plus 3, x plus 3, plus x minus 3, x minus 3, divided by x minus 3, x plus 3. Wicked. To actually add these things, because that's the goal, right? I'm trying to add these two fractions. I haven't done that yet. I've only written them as one fraction. I need to expand the tops. So I multiply these things in to get me x squared plus 6x plus 9. When I expand this side over here, I'm going to get plus x squared minus 6x plus 9 divided by my common denominator, x plus 3, x minus 3. Collecting my like terms on the top, there's 2x squareds. The 6x's will cancel, plus 18. Divided by x plus 3, x minus 3. Now, on a regular test, you might stop right there, and I'd probably give you a mark. But this is not a regular question. This is a numeric response question. And they said that my answer should look like this. This does not look like that. The reason it doesn't look like that is because this a value, they have a monomial in front of a binomial. We don't have that. The reason we don't have that is because I can factor that top. I can factor out a 2. So that I do now have that number in front. And that would leave me with x squared plus 9 divided by x plus 3, x minus 3. Awesome. Now, let's see if we have the right thing. When I look at this, I have a value on the top times x squared plus b. All right, value on the top times x squared plus b. Okay, that looks good. In the denominator, whoa, I just erased everything. In the denominator, they said I should have x minus something, x plus something. I have mine backwards. Now, it wouldn't have made a difference because they're both 3. But on another test, that might make a difference. Because if I'm in the wrong order, then I actually have mine in the order A, B, D, C, where theirs is A, B, C, D. And I might screw up the order of my numbers. So you might just want to rearrange it so that you have it in the right order. Either way, you would have got the right answer. This question, it's probably just good habit to write it in the same order they have it. The answer would have been 2933. I'll put it right below, I guess. 2933. Cool. Last question. Solve that thing. Record the positive solution in the numeric response box. Also, look at this little note on the bottom. This content is neither created nor endorsed by Google. Okay, Google, not good enough for you? Be that way. I'm going to post on your free YouTube site, Google. Oh, my Google on the other side of my living room is talking to me. It said, can you please let me know what I did wrong? Yeah, Google, you didn't endorse my math test. How about that? He said, sorry. Solve this thing. Okay, to solve. I've watched this question enough that I know the thing people probably screwed up was factoring. Because your first step is always factor. And there is part of this that can be factored. So the 6 cannot. The c minus 3 cannot. But I'm going to put it in brackets. Equals c plus 3. I'm going to put in brackets. Divided by that thing can factor. That's a difference of squares. It can factor to be c plus 3, c minus 3. And the important thing about factoring here is it's now something I can simplify before I get my common denominator, where I've seen this question enough that I know people just get so gung-ho about their common denominator that they don't take the time to factor, and then they don't realize that c plus 3 and that c plus 3 can cancel, which means I now have this equation, 6 over c minus 3 equals 1 over c minus 3 equal minus 5. The beauty of doing that and factoring and then canceling out makes my common denominator easier to get, because now look at the denominator, they're both just c minus 3. The second thing people forget to do on this question is they forget that 5 is a divide by 1. So it needs to get that c minus 3 to give me a full common denominator. So if there's 2 mistakes people made, first one, they probably didn't factor. Second one, they forget that's a 5 divided by 1. Now that I have a common denominator, I can cancel out my denominators. This leaves me with Not a Google endorsement, apparently. This leaves you with 6 equals 1 minus 5 times c minus 3. That c minus, or that negative 5 needs to come into the brackets. So I now have 6 equals 1 minus 5c plus 15. If I collect my like terms, the 1 and the 15 can go together. 6 equals 16 minus 5c. I'm going to subtract my 16 to the other side. Negative 10 equals negative 5c. Divide by negative 5. C equals 2. And that was your answer. All right. You survived our last review of 2020. Make sure you hit me up with an email or come into the chat or something, or whatever, to talk to me if you need help with something. Okay? Don't let yourself just sit there and panic. I'm usually pretty decent at responding to emails. I'll try my best to be online tonight so that I can answer emails and try to help with questions. But reach out. Like, I got you, right? It's our last unit test tomorrow. Y'all are going to crush it. I have faith, but ask for help if you need it. Sometimes that's all you need, a little reassurance, a little bit of love. All right. If you haven't, go like and subscribe, because you know what? Random people are doing it. So why wouldn't you do it? I could be Insta famous one day, maybe. Insta famous, YouTube famous, same thing, right? TikTok famous, Insta famous, YouTube famous. I could be a YouTuber. I should start streaming everything I do. Maybe I could be as cool as Logan Paul. Maybe one day. All right. Hopefully not. See ya.